to welcome you all to our National Academy of Construction Ask Me Anything webinar. My name is Keith Molenaar. I'm an NAC member and a professor here at the University of Colorado Boulder. Really thrilled to be with you tonight. The National Academy of Construction was established to recognize our industry leaders. And an important purpose of the Academy is to provide a link between past and future leaders of our construction industry. And that's you, our future leaders. So thank you for joining us. As such, we've established this NAC AMA to help transfer our knowledge to you, our next generation of leaders. The format's simple. Our speakers make a very short presentation about their career and perspective on the industry, and then we answer questions. So I do need you to send in your questions. So if you haven't sent your questions, we do that via email. Just email those in at NACAMA, just all letters, NACAMA at colorado.edu. So you can do that throughout here, but please do that now. From those names, we'll pick one of you for a $500 scholarship, and I'll announce that at the end of the event. So be sure to send that in, NACAMA at colorado.edu, and I'll announce it at the end. So today I'm really thrilled to introduce one of my colleagues and a great mentor of mine, Cliff Schexnayder. Some of you might know him through textbooks in your classes. He'll show you a few. Dr. Schexnayder was an eminent scholar at the Del E. Webb School of Construction at Arizona State University from 1994 through 2003. He holds Bachelor's of Science and Master's of Science in Civil Engineering from Georgia Tech and a PhD from Purdue University. Dr. Schexnayder served in the U.S. Army Corps of Engineers beginning in 1967, and his last assignment was with the Corps was as Executive Director for the Directorate of Military Programs in the Office of Chief Engineers. Thank you for your service, Dr. Schexnayder. After retiring, he joined academia, and that's when he's been teaching and writing all these books. He started his teaching career at Louisiana Tech University and has taught construction engineering at the University of Arizona State University, and in fact all over the world, at Virginia Tech, U.S. Air Force Academy, Universidad de Piura, and the Ricardo Palma Universidad in Peru, as well as in the Israeli Institute of Technology. Without further ado, I'm going to introduce Dr. Schexnayder, and he's got a few slides that I'll go ahead and share for you here. And if you want to just tell me when you're ready to advance the slide, I'll go ahead and do that. So, and Cliff, can you confirm that you're looking at my?
I got it.
Okay,
got
great.
it. Yep. Yeah. Friendly going to high school. Was already at Georgia Tech, so I went over there and they give you a rat hat and cut your hair in those days. I don't know if they do that at universities anymore, but anyway. Can you make it a little smaller so you can see the whole thing on the screen, maybe?
I can't. That may be your screen. So
okay. Anyway, and he's already told you. Went in the Army. They sent me to Thailand building roads. I came back and they go to the next slide, please. They sent me to Thailand, and we built some roads over there and dealt with the mud. They sent me back, went to Waterways Experiment Station, Vicksburg, Mississippi, and all the fellows I was working with in soil mechanics, they said, hey, go back to school and get a master's in construction. You got all that construction experience. So I did. They taught me into it. And then with my good friend Keith there, he's gotten me into a few of these things. Doing work after the earthquake down in Chile, Mao earthquake. That's this wonderful picture of destruction here that I'm standing nearby. And then we actually got a telephone call one day, and they said Peru. I mean, they said Panama, the canal, the third lane. I thought it was a joke at first, but they were serious. So we went down there and looked at their cost estimate, and probably one of the best estimates I've ever looked at, but they had not looked at the risk. And so we had to encourage them to do that, and Keith did a lot of work on that. Last slide. If there's one more, yeah. And like he said, I ran into a fellow named Purefoy who was teaching it while he retired from Texas A&M. And I told him if he ever wants to rewrite the book, I'd help him. And one day he called me up and we did that. Then some other professors said they needed a management book, so we did that. Then they think you know something, so they asked us to write about moving dirt and rock and stuff. Just recently, we've just released a book on building construction, and we got one on quality going on right now with the American Society of Civil Engineers. So I think that's good enough. Let's go ahead and go to the questions.
Well, yeah, thank you again for joining us. And I want to encourage everybody, if you haven't seen the publications on the National Academy of Construction website, ones that we've been talking about this spring are posted there, and we've been talking about the cost estimating series. So this one's really going to be focused on cost estimating. And you know, Cliff, maybe just before I go ahead with their questions, can you just tell me a little bit about your inspiration to write? You know, I know you love construction, you love being on site, you worked as a contractor.
You and I and Stu Anderson at A&M, we worked on a lot of estimating for different owners, agencies, and it's not just the estimate, but what do you do with that information so that you get paid for doing the work? The companies we didn't need practice in building stuff. We had lots of practice. So we want to make sure we get paid. So we were very careful about where the risks were. And that caused me to write this thing about Hoover Dam, because I think it's a very good example, an excellent example. The people with the 6 companies carefully thought about where were the risks, how do I get paid? I know I have to do that first work and get the water moving. So I'm going to put money in there. I'm going to take it out of something. I'm going to think about a better way to do critical items. And that's what we've tried to explain to you in that 8 pages there. I would encourage you to read it if you haven't done that already, because the first part is the estimate. But the next part is to price it so you get paid for doing the work. There's no need to put overhead and profit on an item that then the owner says, oh, I don't think I need that in this job, and so you don't get paid. You didn't do the work, so you shouldn't get paid, that's fine. But you had overhead and profit money there, and you're not going to see it. You lost, it's cost you. So you got to think about what other items are going to be paid, actually going to happen, and not be, if the owner decides they need to save some money, be eliminated out of the deal. You need to, it also identifies the critical items, the ones that, when you make an estimate, you think about the risk of doing a piece of work. And in Panama, there was rock only on the Pacific side. There was no good rock on the Atlantic side. The critical issue was then, how do I get good aggregate to make all the concrete that they had to make? And we're talking about millions of cubic yards. And do we buy it from Canada and ship it down? Or do we crush the rock that's on the Pacific side and haul it through the, well, you'd already be on the other side of the locks, but you had to go across the big lake and deposit it and take care of it. So you have to address those issues of where are the risks in the items, okay? And that's what this is all about. And I guess the whole talk, I'd like to encourage you, you got to think. It's not just calculating some numbers. And I saw somebody popped a question up here about BIM. BIM has improved probably the takeoff part. But you've got to be thinking about the risk. And Go ahead. I think you got that first question. I think that first question took me where I need to be, Keith.
Yeah, let's jump in. And again, thank you for all the writing that you do and all the lessons you leave behind by doing that. We really do appreciate it. Yeah, so Omar has a question. And remember, those of you who haven't seen, we have the whole last 4 Ask Me Anythings. We've talked about estimating, and this one is specifically focusing on bid unit price work. And as Dr. Schexnayder said, this reading focused on the Hoover Dam project. But this question is really a good one, I think. What are some good ways to validate bid document quantities? And you might want to just explain what are bid document quantities as well for our listeners here.
Okay. The owner of a project usually says there's 1 million yards of earth to be moved, 1 million yards of rock. And they'll break it out. Unclassified material, they'll break it out. Rock means that you got to use explosives to blow it up and move. But you need to go and make sure that those quantities are right. The question about the BIM, there's computer programs today that improve our ability to do the takeoff. But to do that, you have to have an understanding of where does the soil stop and the rock begin, and that it's not a clean layer. It's usually got some busted rock and stuff. And you've got to make decisions about, okay, what part is soil, what part is messed up rock, and what part, like we were talking about in Panama, is good rock that I can use to make the concrete with for that job. They gave them some ideas about those, but as the estimator, you've got to make a decision for your company how you're going to do that. We've done takeoffs by hand. We've done takeoffs, like you say, you can use the BIM, and that's excellent. But an engineer has to be thinking to make that decision of where there's the dividing line between the soil, the messed up rock that's not very useful to us, that we may even just have to throw away, waste somewhere, and the good rock then that we can do something with. I've had jobs in the past when I was working for a construction company, and we did our own takeoff, and it was not even close to what the owner's telling us. And we tell the owner, and they say, no, our numbers are right. And we've just had to walk away from the work. It's too much risk. And you need to do that early on. Do a quick takeoff, see if everything computes. The estimate is putting cost on productivity and everything. The takeoff is quantifying the work items to make sure they're correct. So leave it at that right now and go to see if we got another question.
Okay, yeah, thank you. You know, related to validating bid quantities, Molenaar asks one about who's responsible for waste and loss considerations. So in a unit price work, is the lowest bidder responsible for how to handle waste and loss considerations, or how should that be handled?
You're on the kind of what we're talking about, unit price bidding. The contractor, whoever gave a price, it's your problem. You have inherited it. There is some protection, and the courts have ruled on it if they give you some false information. But you have to make that decision about what's good material and what's bad material. I'm thinking of using again the material to say make concrete. I'm going to take the rock and I'm going to use it either to make concrete or do something else that I have to have rock on the project. How you handle that rock, though, you have to, in the estimate, put the right equipment. If you load the hole, shoot the rock, blow it up, and then you run over it with steel track machines, you're effectively crushing it before you ever get to use it. You're affecting the amount of good rock that you're going to have to use on your project. And I have seen contractors make that mistake. The other way is if you're making concrete with it, it's water content. You know what had to deal with in Panama was it rains. It rains in Panama. When it starts raining, you're going to have a lot of water to deal with in your rock. I'm located in Texas today, just north of Dallas. There's a dam job getting ready to start. We looked at similar work in the same area. You got some sticky clays in that part of Texas, and you need to understand that it's going to be very difficult for a scraper to move that material. Even though it's classified as soil, it's a high PI stuff, and if you get a little bit of water in it, it's really sticky. It's like the 4-foot guy is now standing 6 feet tall because he's got mud on the bottom of his boots. It's the best way to tell you about it. You have to carefully study all the information about the project. If I could tell you anything to take away from this afternoon, go walk that job. Go look at the kind of vegetation. It's going to tell you something about the material you're dealing with. Walk it slowly. There was a bridge job in New Haven, Connecticut, right down on Long Island Sound. Well, that part of the world has been settled whenever the Pilgrims came a long time ago. There's a lot of old stuff that's been built on those rivers. Go look at it at low tide and see what you find. You're not going to be able to just excavate soil. You're going to have to excavate soil and old piling and everything else. Take time to actually go look at the work. Next question, please.
Yeah, that's great. I think that relates to Sandra's question, which is how much research is done prior to bid to account for environmental risk? Sure.
Woo! You better do that. Did a dam job out here in West Texas one time. We were going to build condos for the Concho River snakes. Did I tell you? They put it in there. Lots of places around the country, though, you have migratory birds. And so you better read the fine print in the contract documents, because they're going to limit the time of year you can do certain activities. You're not going to be able to mess up the bald eagle. And on the Mississippi River, they're grain elevators. Those eagles just love that spilt grain, and they're protected. There's another job they've been trying to bid in Connecticut almost 20 years now. But there's a couple of eagle nests right there, and it's because it's good fishing where the river comes down in the rapids. How to get away from it. You better understand those things. They're going to affect how you plan the work. So you've only got a certain block of time you can do work. And now you got to think about, how do I do the work in that block of time? That's going to affect your productivity, the type of equipment, everything else. That's going to affect your cost doing the work. If you miss it, then you're going to be delayed a whole year. We talk about it in this paper about Hoover Dam. If they couldn't get the tunnels driven so they put water through it, they couldn't build the dams, temporary dams on each end to start the concrete work on the major dam. They would have been delayed a year. That was a critical item, and you need to think about those things. And environmental is a very big part today. We're dealing with several DOTs, and it hurts. You gotta think. You gotta think.
So great points. I think what I heard there is you have to do more than just look at the bid quantities. You really have to get into the specifications and understand, there could have been more than 10 years of environmental studies done before you work on a bridge, and that's all going to be outlined in there. And there may be fish windows, there may be windows of time for bird migrations, all of those things. And generally, when you bid work, those are all spelled out for you, right? Are there additional items that you might not find in the specifications that you might need to account for when you're bidding work around environmental?
You might think about the environment of the people. If you're close to your neighbors in an urban environment, they really don't like your lights shining in their bedrooms. They don't like all the noise. So you're not going to be able to do certain activities in the evening. But also you can work with your neighbors. When they were doing the interstate work in Salt Lake City for the Olympics a long time ago, and the contractor had to work within 20 feet of some residential, some houses with people living there. What that contractor did, actually, they got the job, but they went out there, and the superintendent and the foreman that was going to have to do the pile driving work right there in the backyard of these people. They hosted a barbecue. They said, here I am. Here's my card, my name, my phone number. If you got a problem, call me, and we're going to take care of it for you. I don't care, day, night, whenever, early morning, call me. I'm going to answer that phone, and I want to take care of it. Just making that offer got those people to work with the contractor, because then they said, okay, here's the days. I need 5 days here to dry these piles, and then I'm going to be finished and out of your backyard. If you tell people the truth, it works a lot better.
It's great discussion. You know, that goes with Nangwin's question. You know, you were just talking about some soft skills and people skills during construction. They were asking here, what kinds of soft skills are important in communicating with design and engineering teams when you're doing estimates?
I'll start with listening to your people, helping your people succeed. I guess it's the slow down, pay attention, turn on this computer, take care of your people. People do the work, whether it's the union laborer or you're a young engineer on the job. I need to take time to train you. I need to listen to what that union laborer says or non-union laborer. And if you do that, then they'll start telling you the truth about what's going on out there, and you can make better decisions. I'm sorry, I run into a lot of people that don't like that idea, but you have got to listen to people, and you got to tell them things, not slapping them, but explain to them why something's important. It makes all the difference in the world. When you work as a team, you can do great things. I guess is the easiest way to tell you that.
Excellent. Yeah, I think so many people forget that the most important part of communication is listening, not always talking or writing, but really listening to your counterparts in the conversation. So thanks. You know, let me just go off a little bit. I have a couple of questions on risk, but I want to make sure our listeners really understand the difference in risk allocation with a unit price contract versus a negotiated contract. Let's maybe take the really current example today with wood prices. If I had given a unit price bid in January for something that had a lot of lumber for forming concrete, who would take the risk for that? Me as the contractor or the owner? What's your thoughts there?
A unit price job, it's the contractor's thing. I would have, and we look at those things. You know, I'm old enough to remember the oil embargo, and fuel prices went up and everything. And you could not, for a long-term project, and it's a risk of any long-term project, and I'm thinking of over 6 months. You cannot lock prices on lots of materials, fuel for your machine things anymore. So you have to be careful. You need to study what's going on in the world, the whole world, about prices. Now, some of the material, the lumber prices, they were what, 4 hurricanes hit Louisiana. Lots of shut down mills. they were shut down for months. So there's not much material. Years ago, there was a lot of work for cement. You couldn't get cement guaranteed prices for long-term jobs. You have to pay attention to what's going on construction-wise in the whole world. There's a lot of work going on in China today that's affecting prices here. Simple example, I need to buy a new dryer. I can't get a gas dryer without 3 months wait time. We are a world economy. It's not just the United States. Now, there will be things like the lumber thing got driven a lot by what happened on the Gulf Coast, because that's a major supplier of softwood lumber. But still, you need to be paying attention, and particularly for longer term jobs. If it's a short term, 6 months less, all right, you probably don't have to worry about it. And that's one reason lots of big companies refuse to bid long-term jobs, anything over 3 years. And they're sureties, they're bonding companies. But warn them about it. Actually, your bonding company is your partner. You say, well, I got to have the bond to bid the work. Yes, but they're trying to tell you about the risk. Listen to what they have to say. They're your partner. They want you to succeed. They don't want you to fail. All right.
Cliff, can I ask you a question, interrupt and ask you a question from Julio? He wanted to know what kinds of insurance or what kinds of bonds do contractors need to carry when bidding public work in particular?
Well, you're going to start with, you're going to have a bid bond. And that guarantees that if you are declared the low bidder and they offer you a contract, you're going to sign on the dotted line and go to work. You say, oh, gosh, I made a mistake because I saw these other bids. Well, you don't have to sign, but you're going to lose that bid bond. And many times that bid bond, the amount has to do with the difference between your bid and the next bidder. So that's what it's going to cost you. And you really don't want that to happen. Then you're going to have a performance bond that you are going to complete the work. Oh, yeah. Well, things aren't going so good. It's not like I thought. This is really sticky clay and I can't get the production. I'm sorry. On these kind of jobs, it's your problem. You made that bid. You're going to have to figure that out. Otherwise, you're going to lose that bond. The other one is the payment and performance. You're going to pay your people. And usually that's covered under workers' comp, but there's some states that don't have that. There's a few. But also, you're going to pay your subcontractors. Those smaller contractors that do all the hard work for you, the specialty people. So you got at least 3 things you got to think about. You're going to sign the contract, you're going to perform the work, you're going to pay everybody. That's typical. And even private owners, unless they've worked with you a long time, and we'll look for a bond. Okay.
Great. Thank you. I think those are really important things when we're talking about bid work like we are now. Let's see, we do have another one that's kind of related. Lots of questions here. Let me see if I can find it again. Cesar is asking, unit price bidding presents several advantages for large projects that may impose big risks. What's one disadvantage compared to other procurement methods? So you might want to mention some of the other ones, but what are some disadvantages of using unit price bidding?
Most of the unit price jobs, the owner has hired someone, an engineer, and usually not even their in-house engineers, say with the Department of Transportation, just kind of oversee. So an external party has designed the work. How much construction experience they have can sometimes be limited. So, but you're going to have to build it the way they have told you. I'm thinking about bridge jobs. The bridge engineer does it the best way he thinks for that. Okay, 20 years from now, the owner wants to redo all those bridges. If the spans are all different, that means you've got to do each one individually. If the bridge engineer in the beginning had thought about making them uniform, distance, girder lengths, things like that, then you would have been able to go in and just replace them one night at a night closure instead of on the traffic lane. They did the Golden Gate Bridge, I don't know, maybe 20 years ago, but it was nice uniform sections. And so they were able to take out a section and put it back in and reopen for traffic in the morning. The engineers were thinking about long-term maintenance and things like that. Design, bid, build. The owner contracts somebody to do the design. That designer doesn't always think about what do you gotta have to do as a builder? What are the restraints? What are the time? All those environmental things you're gonna have to deal with. Some do, but not all of them. You go to design build, now you get your 2 cents worth in there about this design so we can build it efficiently. Or we can do it under those restraints, those constraints that have been imposed by the environment and everything else. That's the one reason contractors like the design build option.
Yeah, I'm going to bring up an example that you and I worked on, Cliff, and that'll relate to the next one. We got a chance to work together on the Bay Bridge, and they bid that project. I don't think they realized the amount of steel that needed to be put in for temporary shoring, right? They unit price bid the decks and everything else, but they didn't realize just the amount of temporary engineering that needed to be there. And back to another pricing issue, steel had doubled on the market, global market, because of China, like you mentioned earlier. So I remember where that was an example where potentially a different procurement method may have worked better.
The owner, because the Golden Gate is the bridge, wanted a signature bridge. So they asked the designer for a signature bridge, and they did what is a self-anchored suspension span. But with a self-anchored suspension span, the bridge does not stand up till you finally set it all there, put all the cables on and tighten them up. Well, that meant that to build that bridge, they had to build a temporary bridge under it to hold it up till they did the cables. We worked for Caltrans. It became a political thing. Had to actually go to the governor's office, but the people in the San Francisco area wanted that signature bridge, and they paid for it. They raised the tolls on the roads. They were competing with the Golden Gate. Sometimes it's political issues or issues of the air. You can't change it. Beautiful bridge, though.
Beautiful bridge.
Fine job. I will tell you that.
Yep.
But, they were not thinking about the material part that way. But the engineer did exactly what the owner asked for. Yep.
That was one too. Braxton was asking a little bit more about bonding. If I recall right, they ended up only getting one bidder because of the bonding requirements were so onerous on that project.
Again, the long-term project, high cost, and so no one wanted to accept that risk. And there have been several jobs. There was the Q Bridge in New Haven, Connecticut was the same thing. The first time they bid it with all the interchanges and all those things, with I-91, I-95. And in fact, they got no bidders the first time. They had to split that job up. And it was the question of the time to build the total project. and that risk and that time and materials that we talked about earlier, and what happened with plywood and everything. No contractor was willing to take that risk. So they broke it into segments where you were doing small parts. You didn't have, I think the first estimate was going to be like a 6 or 7 year project to build the bridge and take the old bridge down. Time is a risk, particularly when you're talking about material pricing.
Cliff, I want to ask you a question, probably based on your experience as a contractor over the years. Nicholas is asking, I'll simplify the question a little bit. How do risk and contingency and profit get added to a unit price bid? What's that decision process like?
That decision process starts when you do the estimate. If you're a young engineer doing part of that estimate, it may be just a small part. But when you see something and you put a production on it, or a crew on it, and a machine on it, you need to write down what you think about that production. What could affect that production? Weather, those environmental things we talked about. And what usually happens, everybody that contributes, somebody maybe did the earthwork, somebody did the structural part, somebody did the drainage, okay? Somebody did the paving. Each one of those has got their loads. And you go in to close that bid, to close that estimate, complete that estimate. You got to go talk to upper management for your company. And you need to make sure you've got those things. You wrote down those risks, those changes that would change that production and that cost. And you explain that to management. And management then has to make a decision. We worked on jobs, and not tremendously big, but big. And management just said, we don't want to accept that. There's more opportunities out there. Bidding is about opportunities to use the talents of your company. So if you can figure out a better way because of the equipment you already own, machines, then management will have a different perspective of accepting things because they think you can do that. But also you're building trust. They want to know the truth. You got to tell them the truth so they can make good decisions. Estimating is not just calculating a cost. Estimating is thinking about those risks and what changes those production numbers, which means cost, and being able to clearly explain that to management, because then they have to make the decisions about how much risk or contingency do we put on this, how much profit. We worked in the Savannah River nuclear plant. The work was not that difficult, but if anything happened, you got shut down. If there was a leak, you got shut down. So you had to put time to protect your people, time in what it was going to take you the term to do all the work they wanted done. We were very fortunate. We had some instances, but nothing major. But still, the amount of profit or overhead and risk that we put on a job. All I do is I move the material and that's it. We understood that risk. And they told you. They didn't believe us at first, but we found out. And then people copied us.
So Hallie's asking a question about risk, again, environmental risks. There's a lot of questions around that. Are there any other ones specifically on the dam? She read the article that you wrote. Any other environmental risks that you would point out there?
I don't have the environmental risk about the animals or things like that. But I lived in Arizona, down in the Valley of the Sun. When it got to 120, I'd still go outside, but you don't want to do much. And we lost people in Arizona that tourists, they were driving through. They get out of the car to go see a flower, go see a cactus bloom. And you don't realize how much water you just evaporate out of your skin. And then they pass out and they die. Okay. If that job in that canyon, the temperatures went up to 140. When that group of companies were estimating the work, that was a critical thing to them. And you got it in the paper that they had to just finally give up until later in August when temperatures receded a little bit. But you got to think about whether it's heat, what we're talking about there, and what you evaporate, and your muscles just close up on you is what happens because you don't have enough salt and water in your body. But cold weather can do the same thing. Built missile silos up in the Dakotas. It gets doggone cold up there, let me tell you. In Panama, it was the question of the rain and the water. How do I keep the water away from things I want to place concrete? I can't place concrete in the swimming pool. I have to have a plan to deal with the water. I have to have a plan to deal with the temperature. A lot of places, even asphalt work or concrete work, has limits about temperature. You have to think about that. We did a bunch of estimates for the feds. They couldn't figure out why these simple bridges were coming in too high. But what time of year they let the job and you have to go to work is critical. So if you were going to have to start a project in November, you can't do the concrete work. You can't get started even. Just the timing of when you're going to be able to go to work is critical. And you need to look at that in the contract documents because it affects your cost, it affects your productivity.
Excellent. Thank you. We're getting close to the end. Time's flying by here, so we have a little more than, well, a little less than 5 minutes actually, but I want to keep asking you a few more questions. So if anybody does have final questions, please quickly get them into nacama@colorado.edu, and we'll try and squeeze them in here. But Braden's asking you to look into your crystal ball, and what do you think the future of construction what's the future of unit price work? Do you see this type of contracting continuing, increasing, decreasing? What are your thoughts on this type of bidding?
It seems to be decreasing. Owners have learned the advantage of design build and construction management type approaches, but there's always going to be some of it out there. And even if you're doing the others, you still go through the same process about the risk when you're figuring the productivity. Yes, you may have input into the design, which takes away some of that risk, but it's there. Anything you're building, it's there. I wanted to build a house in Louisiana last year. 4 hurricanes, I didn't build a house in Louisiana last year. I'm sorry. That's just the way it is. And that wasn't going to be like one of them big projects.
Well, one thing Marcus here is asking about gaining trust, and one idea is that unit price bidding might be we don't trust contractors to give us the best price, so we're going to use unit price bidding. Do you see that, or do you see unit price bidding differently than that?
That's a driver. That's one driver. It's interesting. And the state of Arizona, the highway department started going to design build, but there was this culture from the unit price side. And Mary, who was the head at that time, just had to, if you can't work in this culture, then you go to those other jobs, but we're going to do it together. We're going to work as a partner with the contractors. And the first one was, I'll call it a disaster. I don't know if it was that bad, but it wasn't a good experience. But after that, when you change the attitude, you get people to work together as a team, and that's like your own team, your construction team. When you work together, you can do great things. But they are fearful people. They're private owners that believe that they got to test. And some studies have shown that because of those requirements, You were only getting about 10% of the hour was work. And the rest of it, you were holding up, the owner was holding up the work, doing this testing, this quality control. When they started working together, that went up to 50-something%, almost 70%, somewhere in that range. You got to work together if you're going to accomplish something economically.
Great points. I think if I could add my reflection too, I think we'll probably always see some level of unit price bidding because that's the way some contractors get into the industry. I think it does help you sharpen your pencil and, you know, gives you good data as well. But like you say, there's so many instances when you need trust and you need teamwork to work through some of the complex problems that we face. And unit price bidding is generally not conducive to those types of projects. Let me wrap up with, if you don't mind, Cliff, I've been really appreciate your candor and sharing all of your experience, but Sydney and Tanner, a couple of folks are wondering, what kind of mistakes can you make? What are common mistakes when you're bidding a project, and what might be the outcome? So I'm expecting that not all of your projects went perfectly. Would you mind sharing some of the common mistakes or some of them that you've had?
The mistakes we make are because we go too fast. We get in a hurry. I said, slow down.
Yeah.
Pay attention. I'm bidding a job on the coast in North Carolina. I'm going out there. I always walk the job. I always do my own drilling and soil sampling. Putting that drill bit down and I'm pulling it, but I'm not paying attention. And what had happened, it was a sandy area, but there were layers of clay in there and I missed them. And so I bid it like it was sand. Well, if you're working with sand, you add water. Well, shucks, but with clay, you take water out. I wound up spending a lot more money separating the sand and the clay and then doing my compaction. Probably cost us $1 million, probably. Thank God I had a good boss. He didn't throw me out the window. But almost all the mistakes I know about are because we try to go too fast. I gave a talk to the engineers here in Texas last year, and they said, well, I got to have billable hours. Oh, billable hours is no good if you make a mistake. You want to do it right because they're not going to come back to you if you make mistakes. Slow down, do it right. Take time to think, take time to observe.
Great points. Just like you say, take time to go out to the project site, take time to do the research. Absolutely. Well, that was going to be my last question, but Tara just asked me one more question that I have to ask you. So you could kind of keep it short, but I think she's asking a great question. What would be one piece of advice that you would give a young engineer entering today's workforce?
Oh, that's a hard question. I had a young engineer call me just last week, and he took a good job working for good people in the design business, and he really wants to be in the field. Okay, I didn't know when I got out of school. Be flexible, be a lifelong learner. Maybe that was the best thing the Army did for me. I had to take courses, always, and it got me in that habit. You go to TRB, the Transportation Research Board, you go to the ASCE meetings, you're learning. You're not just going and having a good time, you're learning. Get involved in the profession, get involved in the societies, get involved. Don't just join. And you make friends. Most of the work that Keith and I got was because somebody knew what we were doing and recommended us. Like I said, I thought it was a joke when I get this thing from Panama. Somebody's April Fool joke on me or something. I don't know.
But that's great advice. You are truly a lifelong learner. And I can see how you've grown through every one of these projects, and I appreciate all of the documents and books that you've left so that we all can learn from that. That's great advice. Be a lifelong learner. I really do appreciate that. Well, on that, unfortunately, we're going to have to end. I just can't thank you enough for your time. Any other parting words? I do want to give you just a moment. Any other parting words?
Help other people succeed. Yeah, they call on your time, but you never know. Somebody helped you succeed. Help others to succeed. That's the best thing I can tell you.
Great. Thank you so much. And I think that's really at the spirit of the National Academy of Construction as well. I want to thank all our members who've made the donations for these scholarships possible and everybody who's participated. I want to thank Sandra Pittman and Wayne Crew and everybody in the leadership for organizing this. And now I want to announce our winner. And our last winner for spring here is Tanner Straw from Washington State University. So Tanner, look for an email from NAC and we'll let you know how to get that. One last thank you to you, Dr. Schexnayder, and all the best to your family and everyone, and everyone on the call. I know it's been a tough time through the pandemic. Congratulations on making it through the academic year, and we wish you all the success over the summer and into next year. We'll be back again next fall. So thanks.
Good. Even.